Hi everyone, hope all are doing good, and I am here with the third video of the industrial motor controls. I am going to explain about overload relays. So before going into the topic, we will have a clear idea about what is overload relay and what is a circuit breaker and what is the difference between both of them. These overload relays are very important component or integral component of any motor control circuit. Whenever there is a overload, these relays needs to open the circuit. Yeah, it is very obvious from the name, but how we differentiate between the overload and the short circuit condition? The short circuit condition is nothing but when you have the line to line contact, or the line to neutral contact, or line to earth. So during this time, the current flow will be heavy. The more amount of current will be flowing through the circuit. So the damage could be very fast. So we need to open the circuit or open the breaker very fast, so that it can protect the source and also it can protect the load. And of course, if there is a human involved there, it also can prevent any accident. Right. So then what is overload? Overload is not abnormal current like a short circuit, but it is not a normal current as well. So it is 10 to 15 percentage more than the rated current of a particular circuit. It can be adjusted or it can be tolerated for a particular time, but when it goes for prolonged time period or for a long time, then it can cause the insulation failure, or it can cause the overheating, and it can reduce the efficiency and so many other factors as well. So we need to protect our loads from overload condition. And these overload relay should not trip, or it should not open the circuit during the starting of a motor. Like if you are using a normal circuit breakers, then it would assume that there is a short circuit during the starting of the machine, or you need to have a large tolerant circuit breakers. So these overload relays are designed in such a way that it takes a particular time period so that it will not trip during the start. And if it is sustained or prolonged for a long time, the load current is more, then it will open the circuit. So now let us see what is there inside the overload relay, how it opens the circuit during the fault condition. So as I told you, the load current may be 15 to 25 percentage extra than the normal rated current. Then we can call this as a overload condition. So which can be allowed for certain period, like 5 to 10 seconds, or maybe up to 20-30 seconds as well. It depends upon the motor and the machine and application. In case if this current or the sustained for long time, say 1 minute or 2 minutes, and like that, so then it would cause the problem in the motor and the control circuit. So we need to isolate the motor from that particular problems. And also sometimes we need to indicate why this motor is switched off. Either it is manually turned off, or it is a overload condition, or it could be any other fault. So we will have in overload relay, also we will have a NO contact to show that the motor is turned off because of overload condition, so that the operator of that particular machine knows why the motor is turned off, so that he could take a proper action. Then he will switch on the machine. So I have a constructional view of a melting alloy thermal overload relay. So where we will have two terminals or two contacts. You can see here the main motor supply, the main power source is connected through the coil or a mechanism which has melting point, melting element. So here the current start flowing through this. So the current start flowing through this conductor or a path, so to the motor. So when the motor is running in a normal condition, and the normal operating current is flowing through this, doesn't make more temperature here, doesn't heat up this heating element. And here based on that, because of that, here the contacts are being getting closed. So these contacts are this NC contact is getting uh, connected to the magnetic coil of a main contactor. So the overload relay and then the main contactor. So the current flow is going to the contactor coil. So the contactor coil may be holding the contact, and because of that the motor is keep running. So in case the motor current here is exceeding the limit by 25% for a long time, like 20 seconds, 30 seconds, then what happens, this melting element or the heating element, the temperature goes up, and then because of the temperature going up, it pulls this contact up. When this contact is pulled away, so what happens, here the circuit will be opened. Here only the NC contact is shown, the NO contacts also available in the overload relays. So when the contact is broken here, the current flow to the control circuit will be stopped. So when the control circuit current is not flowing to the magnetic contactor, so what happens, the contactor is getting de-energized. So obviously wherever you use the contacts of it, either it is auxiliary contact or main contact, it will open the contact, so or it will come back to the normal state. So the motor will be off, and the indicators, if you in case you use the indicators will be indicating the particular condition as well. So this is how the melting alloy thermal overload relay functions. And the element, the heating element which I have shown you here will be like this, a bimetallic type. Sorry, that is a different element, and the bimetallic type overload relay is also available. So this bimetallic type, we have different metals, connected together or kept together because of the temperature, coefficient, different temperature coefficient. When the heat is given to this particular element, it start bend. Okay, so because of this displacement in the position, so it can open the circuit. So let us see how it is used here. So this is a internal construction of a bimetallic overload relays. So here I have adjustment knob. So based upon the tolerance or the current with current setting, how much you need, so you can adjust this bimetallic adjustment knob, so that you give the tension here, so which is proportional to the current which you need to allow through this device. And we have a bimetallic strip here. This is a bimetallic strip, so the current enters here and then the current may leave here. So when the current exceeds the normal rated current, then the bimetallic strip, the temperature is increasing, and because of the temperature increases, then it will start bend, the deformation in the shape causes the contact to open. So here this contact to open, so this will pull down. Okay, so when this pull down, this NC contact will go up. So when this go up, so that means the current flow is obstructed or stopped. Okay, so this is how the current flow can be stopped during the overload condition. So this is a main contact. So here, where you need to monitor the load. So the load current will be flowing through this heating element like this, and it will go out. And this part is for the control circuit part, where you want to break the supply to the magnetic contactor coil. So that will be connected here, one input terminal and output terminal. So this is a NC contact. In case of overheating, so this armature or this setup will go up. So when it goes up, comes down. When it comes down, then it, with the mechanical pressure, it goes up, so that it will open the contact here, so that the control circuit power will be broken. So when the control circuit power is broken, so automatically the contactor will de-energize. When the contactor is de-energized, then the current flow through this part will be removed. So the temperature, when the temperature decreases, and it resets to the normal condition. How to represent them in the control circuit? So we have two elements. One is the heating element, which I represent like this, and another one is contact. So this is the NC contact of this thermal overload relay. I can use also NO contact for indicating the fault. In case if there is a fault, then that particular contact can be closed and it can show the indicator. So here, if you see, in a normal condition, from the bus bar the current goes through here, and when the start push button is pressed, so the current will flow through the main contactor, and the main contactor is get energized, and this is the NC, so it will allow the current flow to the neutral. And when the main contactor is energized, then the contact here will get closed like this. So this will get closed and this will get closed. So when these two contacts are getting closed, the motor start running. Okay, in case of the excessive current, say for example you have 125 percentage of the current. Okay, so in case it sustained for long time, then what happens, this coil get heated up, the temperature goes up. Okay, the temperature of this coil goes up, and because of this is going to open the contact here. When this is opened, then what happens, then automatically the current flow in this path will be stopped. When this is stopped, then it is getting de-energized, the main contactor is getting de-energized. So because of that, here it will go back to the normal condition. So that means it will open the contact, so the motor will be off. So this is for single phase motor. In case if you are using the same single phase overload relay for three phase motor, we will use three single phase overload relays like this. The coil and the related contact, the coil and related contact, the coil and related contacts, all these are connected in series. So if any one of them have the temperature higher, so if this particular line is having more current, then in some cases, unbalanced condition, that is also possible. In any one particular line is having more current, then the overload coil here or the overload element here will open the respective overload contact. So if any one of these contact is open, then automatically the motor goes to off condition. So in some condition, all these three, in balanced load condition, but it is a overload condition, in all the three contacts or coils also get heated up, and all these three contacts will be opened up as well. So if you are using a single phase overload relay, so this is the way you will have a three NC contacts connected in a control circuit, and the three single phase overload relay connected in the power circuit. In case if you have a three phase overload relay, you will have a three heating elements, but you will have only one overload NC contact. So if any one of these overload relay contact is the coil is having more amount of current, if the current is more here, so what happens, if anyone, either here or the L2 or L3, any one of these heating element is having more current, or the current flowing through the heating element is more, this overload relay contact will open and it will break the circuit. So the motor will be in off condition, and it will be protected from the abnormal load conditions. So this is the wiring diagram. So we need to see a control circuit and uh, power circuit. So here, so this part is called as a, this part and above is called as a power circuit. So this part, the top part is a power circuit, and the down, this part is called as a control circuit. So in a wiring diagram, we will have a two different part, that is one is control circuit as well as one is power circuit. So if you see the wiring diagram of this simple motor control, we have, as I told you, we have a control circuit and we have a power circuit. So we have a three phase line supply here. Okay, so which is given to the contactor input terminals, and the contactor output terminals is given to the overload relay coil or a overload relay element, heating element. Okay, so all these three heating elements, and then from that output it is given to the motor. So this part is a power circuit, and in the control circuit we have taken L1 and L2, both of them. So in some cases we need only L1 and neutral. In case if we have a neutral, L1 and neutral also can be taken, and based upon the requirement of this relay coil or a contactor coil, how much power supply is needed. Sometimes it may be 240 volt AC, sometimes it is 24 volt AC, based on the relay coil size and the contactor coil size. So the control transformer can either step down to the particular value. So here, after the control transformer, the current start flowing through this stop switch, and then it goes to the start switch, and the current flow goes to the contactor coil, and after the contactor coil it goes to the NC, that is a NC terminal of the overload relay, and it goes back to this transformer, another terminal. So this is how the circuit is getting closed. When the current flow takes place in this path, then the contactor coil is energized, so these contacts will get closed. When these contacts are getting closed, these are main contacts, and this is auxiliary contact, these also will get closed. So this auxiliary contact is connected just parallel to the start push button to provide a latching operation. So when the latching is done, you can release your hand from the push button, so that the latching takes place. The latching process makes sure that the current continuously flows to the coil. Then we also have overload indicator contact here. So this is a normal condition. So when the current flowing through this main contactor, so either here or here or here, any one of these, if the or all of them having more current, then what happens, the coil or the overload mechanism get heated up. Because of the high temperature, it will open the circuit or it will close the circuit. So it will open here in the NC and it will close here in the NO. So here, since it is getting closed, what happened, the indicator start glowing here. Since it is opening here, it will break the circuit for the main contactor. So when the main contactor circuit is broken, so what happens, so the current flow to the main contactor will be stopped. So it will make sure that it will de-energize this contactor coil, so it will push back the contactor into normal condition. So here it will go to the normal condition, so that the motor can be protected from the overload condition. And it shows the indication here, there is a overload condition, because of that the motor is stopped. So when the operator comes there, he will know that the motor stops because of overload, so he will take a proper action to prevent the motor from overloading. So this is the purpose of overload relay. Hope you understand the overload relay and its function, and how it is getting connected to the three-phase machine. In case if you have a three-phase overload relay, how it has the contacts, and in case if you have a three single-phase overload relay, how it is connected in your motor controls. We have seen it and hope it is clear. Thank you for watching.